This video is about correlation coefficient R. Correlation coefficient R measures the strength and direction of a linear relationship between two variables. R, the correlation coefficient, this is a symbol for it, R, and it takes on the value -1 to +1. Okay, so it cannot be a number outside of these two. So you cannot have a correlation coefficient that is 1.7 or 5 or 10 or -3.4 or -1.5. The largest it can be is 1 and the smallest it can be is -1. Okay, so it takes on any value between these two numbers, including these two numbers. Okay, all right, let's see. R, when R equals 1, that is a perfect positive correlation, and it looks like this. It forms a perfect line. So what it means, as your x values get larger, your y values also get larger. Okay, it will always look like you're going uphill, always, for every positive. Okay, now if R equals 0.8 or any value closer to 1, we call that a strong positive. And that's what it means when it says strength and direction. So this is what we're talking about. Strong, that's the strength, all right? Positive, that's the direction. The graph of it will look like, a perfect line, but just that all the dots will not be in the same line. Okay, you'll have a few probably off like that. It will look something like that, all right? But it will look like a straight line. All right, if R is 0.5 or anything like 0.6, 0.65, 0.7, we say that is a moderate positive, and it looks something like a moderate positive. The points will be a little bit further away. Okay, but it will do maybe something like that. It's still going uphill. You still can form a line between it like that. Okay, all right. So let's look at other cases. All right, let's explore when this thing is negative and otherwise. Okay, so if R equals -1, then we call that a perfect negative. Perfect negative. And the graph, the negative will always be going downhill. So as your x values increase, then your y values decrease. So it will always look like you're going downhill, but it forms a perfect line. Okay, all negative correlation will be going downhill. Okay, all right. So if R equals -0.8 to anything closer to -1, we call that a strong negative. Okay, and you still be going downhill. The points will look like it's a straight line, but they will not all be in the same line. So it will look maybe something like that. All right. Now, if we have R equals -0.4, anything below 0.5, whether it's negative or positive, we say that is weak. Okay, and that's how we describe it, tell the strength and the direction of it. So the graph, so we say this is weak negative. All right, and the graph of it still be going downhill, but it will be, the points will be further away. Okay, points will be further away. So you still can see that it's clearly going down. Now when R equals 0, there is no correlation. No correlation. And in this case, you cannot tell the direction of it. You can't tell the direction if it's going up or if it's going down. So the points pretty much all over the place. Okay, there's no pattern to it. You can't tell if it's going up or it's going down. This is no correlation. Okay, so when they talk about the definition says that correlation coefficient measures the strength and the direction. The strength talking about, like you're saying, it's positive or it's moderate, it's strong, it's moderate, or it's weak. Okay, the direction is saying that it's negative or it's positive. Okay, so that's what it means when it says measures the strength and direction. Alright, let's look at an example. So this question here, it says the relationship of a woman's shoe size and the length of a woman's foot in inches is given in the accompanying table. So here's the table, and it says find the linear regression line, and linear regression line is the same thing as your line of best fit. So most cases you'll see this term, line of best fit. Okay, it also asking us to find and describe the correlation coefficient. Alright, so here we go. We hit start, enter, we see some data in our table, and let's clear those, and let's come over here and clear that as well. In fact, I'm going to clear the entire calculator because I want you to know how to manipulate your calculator just in case you come upon a situation wherein you're not seeing R. Okay, so let me clear my calculator and take you through the entire process, how we put in the data, how we interpret R, and all that kind of thing. Okay, alright, here we go. So we hit start, enter, we see that there's no data in the calculator, so let's put it in. So it is 5. All the values at the top here, these are your X values, and the ones at the bottom, those are your Y values, always. Okay, or if you see a situation like your table looking like this, that will always be your X and this will always be your Y. Even if it's not labeled X and Y, you will always have this column here being your X and this column here being your Y, or the one at the top being your X and the one at the bottom being your Y. Okay, so we have our 5, 6, 7, 8. Now let's come over here. We have 9, 9.25, 9.5, 9.75. Okay, then we hit start again, come over to calc, come down to linreg, and we carry it down to calculate, and there we go. It asks us for the line of best fit. So our line of best fit A is y equals ax plus b, but our A value is 0.25, so that is y equals 0.25x plus our b value, which is 7.75. so this is our line of best fit. Okay, the second part asks us to find our correlation coefficient R, but if you look on the screen, you're not seeing any R value there. So to find your R value, if you come across a situation like this, you're going to hit second and then the 0, which is the catalog. Okay, and you're going to scroll down until you see diagnostic on. Okay, when you see diagnostic on, you're going to hit enter 2 times. So here we go, diagnostic on, hit enter 2 times until you see done, and then you clear it. Alright, because the data is already in your calculator, hit start again, come over to calc, come down to linreg, and then calculate. Now you're seeing your R value. So our R value here is 1. It asks us to describe the correlation coefficient. Alright, so in describing this, you must describe the data in context of the question. So the question is about woman's shoe size and foot length. So because R is equal to 1, then you would say that there's a perfect correlation or a perfect relationship between a woman's shoe size and her foot length. That's what it means. Okay, so there's a perfect relationship or correlation between a woman's shoe size and her foot length. Okay, I hope you learned something today. Have a fantastic day.